Mensuration, lecture number 1, circles. Now, when we talk about circles, let's just say that a circle is given. In this circle, you have been told that there is a center of the circle. In the center of the circle, we are creating two different sectors. Now, this sector, this part is your minor sector. This part is your minor sector, whereas this part becomes your major sector. So that means the smaller part is your minor sector, where this becomes your major sector. Now, in this minor and the major sector, if this is theta, theta is the angle, this angle will be the reflex angle, which will be 360 degree minus theta. So that means if, let's say this is 60 degree. So if this is 60 degree, this should be 300. If this is 80 degree, then this should be 280 degree. If this is 40 degree, then this is 320 degree. So whatever the angle will be, you'll be subtracting it by 360 to get what? To get the angle, that is the reflex angle of the circle. Now, the major part of this is that in the circle, there are two particular things. One is the area that you should be known. Area of the circle is pi r square. Area of the circle is always pi r square. Whereas the circumference is the boundary of the circle or the perimeter. This should be 2 pi r. So the two general formula of the circles are, that means if I want to find out the area of the circle, that means complete area of the circle, this should be what? Pi r square. This will be pi r square. Whereas if I want to know the circumference, the complete boundary of the circle, is known as your circumference. When I want to know the circumference, that is basically 2 pi r. R is the radius. R is the radius. So if R is the radius here, so we can take down this line and this line, because a radius is the line which connects with center of the circle and meets one point at the circumference. So this becomes your radius, and this line becomes your radius as well. So if this is 5, then automatically this will be 5 as well. So what I want to understand here is, if I want to find out the area, then I'll be taking down the radius that will be given in the question. I'll put down that radius in the formula and I'll multiply it with pi. Now, normal pi value is 22 upon 7 or 3.142 and the decimal places, but generally we'll be taking the exact pi value if we are doing it in paper 2. That will be in the calculator. So to find the value of the pi, we can also do the shift in the calculator, that is always on the top left side, where we can use shift and the button that has 10 to the power x, which will give me pi. So pi will have the general value of 22 upon 7, which means it will have all the decimal values, and when we will multiply with the radius, you will eventually get the exact value of the area. Now, this is your area, that is pi r square. Then the circumference, that is 2 pi r. Now, considering, let's just say that we have a circle. Let's just draw a circle here. Now, this circle has a radius of, let's say, a radius of 10. Now, nothing else is given, it's just the radius. Now, when it's the radius that is given, so we can find out the area. So, area is pi r square. So, this should be pi 10 square. So, 10 square is 100. So, if I want to express the answer in the form of what? Pi, then 100 pi will be the answer. If I want to express the answer in terms of pi, then 100 pi will be the answer. But in the general form, when I want to find out the value, then you need to calculate it. That means 100 will be multiplied with what? Pi, which is 314.1. So 314.1, if we just leave it in the 3 significant place, so this should be 314. For general formula, that is your area pi r square. Moving on to circumference now. Circumference formula is 2 pi r. Circumference formula is 2 pi r. So 2 pi is same, but obviously r becomes what? 10, which is 20 pi. Now, if you want to express the circumference, you will leave the answer in terms of what? 20 pi. Or when you solve it, what will be the value of 20 pi? 62.83. So 62.8 will be the circumference of the circle. Now, what does it shows? Basically, this shows that 62.8 is the boundary. The total length of the circle is 62.8. This will be 62.8, whereas the area itself of the circle will be 314.1, which will be 314.1. That means the area that is being considered with the help of what? Radius. So circumference is 62.1, but the area will become what? 314.1. Moving on. If we have this circle, now as I said, that these are the two particular things that are given. This is your area, this is your sector, but this will be your minor sector because this is your smaller sector. And this part, the entire part, will be your major sector. This will be your major sector. Now, if we think about the minor sector or the major sector, we will basically think about the area that is being taken by the major sector or the minor sector. Let's just work upon this. Let's just say that this becomes your circle, and in this circle, we already know that we have a center, and let's say this becomes your sector. Now, this has the radius 10, and let's just take this angle as 60 degree. Let's take this angle as 60 degree. Now, if we just work out with the formula, if I want to find out the area of minor sector, or the examiner can ask area of the major sector. So you must realize one particular thing, that this minor sector or major sector is basically in the circle itself. Your minor sector and the major sector is in the circle itself. When it is in the circle itself, so that means that you already know that the entire circle area formula is what? Pi r square. Your entire circle area formula is pi r square. But your sector will have the area which is less than the circle area. Automatically, your major sector will also have the area which is less than the circle area. But how do we find out the area of the sectors? That will be through the ratio method, ratio technique. The ratio technique says that your formula that you will be creating will be based upon the ratio, which is theta upon 360 into pi r square. That means now you need to understand the formula. This pi r square is basically the formula of the circle. This pi r square is basically the formula of the circle. This formula, pi r square, is being multiplied with the ratio. How do we find out the ratio? The entire angle that the circle comprises of is based upon 360. But if I want to find out the area of the minor sector, the angle of the minor sector is what? 60 degree. The angle of the minor sector is what? 60 degree. So what will be the ratios? That will be 60 upon what? 360. 60 upon 360 will give me the ratio of the minor sector against the entire 360 degree angle. Whereas if you work upon this smaller, the major sector is what? Major sector will be what? 300. Your major sector will be 300. So if I want to find out the ratio of the major sector, your ratio of the major sector will be 300 upon 360. That means your angle that the major sector has upon the total angle that the circle has, upon the total angle that the circle has. Whereas if I want to find out the ratio of the minor sector, this would be 60 upon what? 360. That means the angle of the minor sector, that is 60, upon the angle of the entire circle, that is 360. But what do I need to find? I need to find out the area. I need to find out the area. And the area comes from what? Circle. The area comes from what? Circle. Circle area formula is pi r square. Circle area formula is what? Pi r square. So can I particularly say that now, since I know that theta upon 360 is the ratio, where this pi r square will be the area of the circle. The area of the circle will basically multiply with the ratio of the minor sector or with the ratio of what? The major sector, depending upon the angle that will be given. In this question, it is 60 degree for the minor sector. There might be a possibility that the angle might be 80 degree for the minor sector. There might be a possibility that the angle could be 70 degree for the minor sector. So at this time, if that is 70, that would be 70 upon 360. If that is 80, it would be 80 upon 360. If that is 40, then it will be 40 upon 360. But the entire ratio concept should multiply with what? Pi r square, because the area itself will be through the pi r square formula. So in this question, if I just work out that I need to find out the area of what? Area of minor sector. What do I need to find? Area of the minor sector. So area of the minor sector means 60 upon 360, because the angle is 60, right? We just got to know the angle was 60. Multiply by what? Pi, and your r was 10 square. Multiply by pi 10 square. So if we just work upon the area, and I just want to simplify this so that we can just work upon the ratio as well. So 60 will be, this will be 1 upon 6. This should be 1 upon 6. That means the ratio of the minor sector is what? 1 upon 6. Multiply by what? Pi 100. That means 10 square is what? 100. Moving on, if we just know that this should be 100 upon 6 pi. This should be 100 upon 6 pi. We can simplify this. This should be 50 upon 3 pi as well. This can be 50 upon 3 pi as well. 100 divided by 2 is 50. 6 divided by 2 is what? 3. So if I want to express this, I can express this as what? 50 upon 3 pi. If I want to generally express this, I can express this as 50 upon 3 pi. So this particular thing will be the area of the minor sector. But if I want to calculate in the calculator, you need to take out your calculator and calculate this. So 50 upon 3 multiply by pi. This should be 52.35, somewhere close to this. So let's just take 52.4. So the area of the minor sector will be 52.4. Now with the same question, I need to find out the area of the major sector, because the examiner can ask me area of the minor sector. The examiner can also ask me area of the major sector. For major sector, what will be the angle? The angle will be 300. For major sector, the angle will be 300. So let's just take the ratio now. So area of major sector will be theta upon 360. The formula is same for both. It's just that you need to understand which angle to use. So if I want to find out the major sector, the angle of the major sector is what? 300. So can I particularly say that 300 divided by what? 360, because 300 is the angle, multiplied by what? Pi 10 square. So if I just work out with this should be 5 upon 6. So the ratio of this is what? 5 upon 6. Multiply by what? 100 pi. Everything is same, just the ratio has changed. Everything is same, just the ratio has changed. So this should be what? 5 upon 6. So this should be 500 upon 6 pi. This will be 500 upon 6 pi. So if we just multiply by what? 2. So this should be 250 upon 3 pi. This should be 250 upon 3 pi. So if the question says express it in the pi, so this should be the answer, that is 250 upon 3 pi. Or the answer when we put down this thing in the calculator will be, the answer will be 261.7. So this will be the area of the major sector. Now you need to understand this thing. Now see, this is the concept that we are working on. The concept here states that the area of the major sector is 261.7. The area of the minor sector was 52.4. But these both areas are from what? Area of the circle. These both are from the entire area of the circle, because we took it out from the ratio. The entire circle area was 314. The entire circle area was what? 314, because the ratio was, the radius was what? 10. The radius was what? 10. Because obviously if I want to find out the entire circle angle, I do not need the angle for this. I will only be needing the radius. So I had the radius, I calculated it, it was 314. So if we just add these two values, let's just say that area of minor sector, and let's say area of major sector. We are adding both. So area of the minor sector was 52.4 and the area of the major sector was 61.7. So if we add both of these, 52.4 and 261.7, the answer will be, adding both of these values, 304.1. The answer is what? 304.1. And the circle area, when we use what? Pi r square, which was pi 10 square, which was 100 pi, answer is also 314.1. So this is a clear indication that area of the minor sector and area of the major sector, basically it comes from what? Area of the circle. And it is just because of the ratio that we are using. For the same question, the ratio was 60 upon 360 for minor, and for major it was 300 upon 360. Both ratios, when we multiplied with pi r square, we made sure that we get the answer of what? 52.4 for the minor and 261 for the major. So this was what? Area of the minor sector and area of the major sector from the area of the circle with the respect to the ratio for minor and major. Now, working on the arc length. But before arc length, we'll make sure we understand the circumference formula. Your circumference formula is 2 pi r. Now, circumference is basically what? Is basically your perimeter of what? Circle. Perimeter of what? Circle. So if I say that we have been given a circle We have a circle with the same thing that we say that the radius is what? 10. Now, when we want to find out the area of circumference, the circumference does not need the angle. So this is 2 pi 10, which is what? 20 pi. So if I want to express the circumference, the answer would be 20 pi. Or when we want to solve this, then the answer will be 20 multiplied by pi. That will be 62.8. So this will be your perimeter. We actually calculated this in advance. Now, let's just work upon the sector. Let's say, now this thing becomes your sector. Let's say this is 60 degree. So if this is 60, then this should be what? 300. So there are two things that the examiner can ask us. Again, the two following things are arc length of minor sector, and arc length of major sector. So the two following particular things that we need is arc length of the minor sector and the arc length of the major sector. Now, first we need to understand what is minor arc and the major arc. So this is your minor sector, right? So the boundary of the minor sector is this. This will be the arc length of the minor sector. This boundary will be the arc length of the major sector. This will be your arc length of the major sector. This is your arc length of the minor sector, and this is your arc length of the major sector. But you need to understand again, the entire thing is from the circumference. The arc are coming from the circumference. The circumference formula is 2 pi r. The circumference formula is 2 pi r. Again, I need to find out the arc length. That means part of the circumference. Now, if I want to find out the part of the circumference, that means I need to find out the ratio first. Then the ratio will be 60 upon what? 360 for what? Minor, and 300 upon 360 for the major. So that is the reason the formula for this will be, which will be equally used by both, theta upon 360 into 2 pi r. So when we are working with the what? Arc length, we will be working with the circumference. That is what? 2 pi r. And we'll be using the formula of what? Theta upon what? 360. So that means that if I want to find out the arc length of minor sector, which will be 60 upon what? 60 upon 360 into 2 pi 10, which will be 1 upon 5, which will be 1 upon 5, 1 upon 6, 1 upon 6 multiplied by 20 pi, 1 upon 6 multiplied by 20 pi, which will be 10 upon 3 pi, which will be 10 upon 3 pi. If I want to express the arc length of the minor sector, 10 upon 3 pi will be the answer for this. But if the examiner wants us to calculate the arc length of the minor sector, then 10 upon 3 pi, we'll put down this thing in the calculator and the answer will be 10.47 will be the answer for the minor arc length. Similarly, the question can be arc length of major sector. Arc length of major sector. So the formula still remains same, theta upon 360 into 2 pi r, because we are talking about the arc length. Arc length comes from the circumference. So circumference formula is what? 2 pi r. So the major sector angle was what? 300. So this should be 300 upon 360 into 2 pi, and the radius was what? 10. So this should be 5 upon 6 multiplied by 2 pi 10, which will be 20 pi. Let's just write this thing down as what? 20 pi. So 20 pi means it should be 520 is 100. So this is 50 upon 3 pi. If we want to express this will be what? 50 upon what? 3 pi. So 50 upon 3 pi, when we multiply it in the calculator, what we'll get? Which will be 52.35, which can be written as 52.4. 52.4. Now, what we know here is that we are working down with what? Arc length of the major sector. We worked out with arc length of the minor sector, but that major sector and minor sector for the arc length comes through the circumference. Circumference formula is what? 2 pi r. So if we just add this 52.4 plus 10.47, 52.4 plus 10.47, this both sum will be equal to what? 10.47 50 will be equal to what? 62.8. That means that the arc length is coming through what? Circumference. Why? Because the radius for all the points are same. And since we are taking out the same, from the same circumference, we are taking out the arc length. That means automatically we'll be working down with the ratio of the minor sector, which is 60 upon 360, and the ratio of the major sector, which is 300 upon 360, to have the arc length of the major and the minor sector. We have done the area of the sector, that is minor major. We have done the arc of the sector of minor and major. Before we move to the other part of the segment that is included in the circle, we need to understand the area of the triangle in the circle. So this is your circle. Let's say the circle has the radius and there is another radius. Let's say this radius has a chord. Oh, I mean to say this 2 radius has a chord. When the 2 radius has a chord, if I work down or through down the properties, this will become radius and this will become radius. So that means it will become an isosceles triangle. This will become an isosceles triangle. What does isosceles triangle mean? When 2 sides are equal, that means 2 opposite angles are equal. But at the moment, we are not working down with anything else other than the area. So what does area do? Now, normal area formula is half into A into B into sine theta. Your general area formula of the triangle is half into A into B into sine theta, where we take out the area of any non-right angle triangle with the angle and the 2 adjacent sides. With the angle and the 2 adjacent sides. In this particular triangle, the angle is given, that will be your theta, but the 2 adjacent sides will be the radius now. The 2 adjacent sides will be the radius. So the formula in the mensuration becomes half into your A and B are the adjacent sides, which will be R into sine theta. That means the 2 adjacent sides will be basically the radius that we are talking about, right? Because this is your isosceles triangle inside the circle. So that means your formula of the triangle will be half, the area of the triangle will be half R square sine theta. So the formula of the area of the triangle will be half R square sine theta. That can be taken out using the given particular triangle in the circle. Now let's just say that in this circle, we can take down the radius as 10, and let's take out this theta as 60 again. So if I want to find out the area of the triangle, your area of triangle formula is half into A into B into sine theta normally. But in this mensuration, your formula becomes half r squared sine theta because both the adjacent sides are your radius. So if I want to find out the area, this should be half 10 square into sine 60. This should be 10 square into what? Sine 60. So if I want to find out the area, this should be 100 upon 2 sine 60, which will be 50 sine 60. Which will be 50 sine 60. Value of the sine 60 in the calculator when multiplied by 50 will be 43.3. Now this 43.3 is the area of the triangle, the entire area of the triangle. This through the formula of what? Half r square sine theta. But this is formula that comes through what? Half AB sine theta. That came through what? Half AB what? Sine theta. So this triangle area is important. The triangle area is important because now what we are doing is the minor segment and the major segment. So we need to understand the minor segment and the major segment. So here is your circle again. So let's just work out with the circle, your minor segment and the major segment. So this will be area of what? Area of segment. So again, we will have two segments in the circle. This is your radius, and let's say this will become your radius, right? So these are the two radiuses, the radius, and this is your other radius. Then what do we have? We have a chord. We have a chord. Now, if we just work out with this thing, we can see that the triangle itself, this is your smaller part, this part after the chord. There's this part and there is this part before the chord. Now, after the chord, this is your minor segment. After the chord, this is your minor segment. Whereas before the chord, this will become your major segment. Now, if you just look at this becomes your sector. This becomes your sector. If I subtract my area of the triangle from the sector, I will be getting only the unshaded part. I'll be getting the answer of the unshaded part. That unshaded part is the minor segment. This unshaded part is your minor segment, which I'm shading it now. Remember, area of the sector minus what? Triangle. When I'm subtracting the triangle from the minor sector, I'm subtracting the triangle, I'll be getting the area of the unshaded region. Now, similarly, this part is your major sector. This part is your major sector. When I will add the triangle in this major sector, I will get the area of the major segment. I will get the area of the major segment. So there are two formulas and there are two requirements, which means the two requirements are area of minor segment. So generally the area of the minor segment will be through what? This will be through area of minor sector minus area of triangle. Minus area of the triangle. So let's just work upon this thing. Let's say that This is 60 degrees, the radius is 10, right? So we got to know that the area of minor sector, we already calculated this. If I want to find out the area of what? Minor sector, this should be 60 upon 360 into pi 10 square, which was 1 upon 6 into 100 pi, and this was 50 upon 3 pi. The area of what? What? Minor sector. The answer for this was 52.7. The answer for this was 52.7. We also calculated the area of the triangle previously. The area of the triangle was half r square sine theta, half 10 square sine 60. So this was 100 upon 2 sine 60, which was 50 sine 60. And the answer for this was 43.3. So now what we need to do is, we need to understand that this is your minor sector and this is your what? Area of the triangle. So what we need to understand is 52.7 area of the minor sector minus 43.3, which is 9.4. Why do I need to subtract it? I need to subtract it because I need to have the area of what? Minor segment, which is this. And this comes under through what? When I know that this is your sector and the triangle is subtracted from the sector, I will get the minor segment. Similarly, on the other hand, if you just notice that I can also calculate the area of what? The area of the major segment. So if I want to find out the area of the major segment, so to find out the area of the major segment, what is needed? Area of the major sector plus area of the triangle. So can I just take down the answer for this? Area of major sector plus area of triangle. So to calculate the area of the major sector, we already have done this, but to make sure that we understand this should be 300 upon, this is 300 upon 360 into pi 10 square. The answer for this was 300 upon 360 into pi 10 square. The answer was 262. And the area of the triangle that we calculated through half r squared sine theta 10 square sine theta. The answer was what? 43.3. So what we need to do is we'll be adding them. So if we just add 262 plus 443.3, the answer will be 305.3. Now you need to lastly understand one thing, that the minor segment and the major segment is also coming from the circle. The circle area was pi r square pi 10 square, which was 100 pi. So 100 pi was 314. So if we add the what? The area of the minor segment and area of the what? The major segment, we will again have the area of the circle. So area of the minor segment was 309.4 and area of the major segment was 305.3. So if we just add these two values again, I'll be again getting closer to what? 314. So the entire part of the circle is done here, where we concentrated, where we worked upon the area of the major sector, area of the minor sector, that came through the formula of theta upon 360 into pi r square. Then we worked upon the arc length of the major and the minor, that was theta upon 360 into what? 2 pi r, right? And then we worked upon the area of the triangle, which was half into r square sine theta, which was half r square sine theta. Then we worked upon the minor segment, which was area of the minor sector minus area of the triangle to have what? Area of the minor segment, and the major area of the major segment, which was area of the triangle added to area of the major sector.